going to discuss about oxidation number, what it is, and how to find the oxidation number of an element in a compound. You should be able, after this video, you should be able to define oxidation number of an element in a compound and identify elements with fixed oxidation states and those with variable oxidation states. You also be able to find the oxidation state of an element in its compound or radical. I want you to go back to your electronic configuration and see if you can answer the starter question. Using the electronic configuration, identify the valences of the element shown below. This is sodium. This is its electronic configuration, which is 281. This is oxygen. Its electronic configuration is 26. If you look at this, can you identify the valences of sodium and oxygen? If you look at the configuration, sodium has one electron at the outermost shell. So to have octet structure, sodium will lose one electron. So the valency of sodium is 1. And in oxygen, to have octet structure, oxygen will gain 2 electrons. So the valency of oxygen here is 2. So I believe you have the knowledge of valence because that will help you in the oxidation states we are going to discuss. Oxidation number or state. What does this mean? The oxidation number or state of an element in a compound is the number of the total number of electrons that an atom gains or loses in order to form a chemical bond with another compound, another atom. The oxidation number or the oxidation state of sodium in sodium chloride is the total number of electrons sodium lost in trying to combine with chlorine. That is what we mean by oxidation number. Oxidation number of an element in a compound is the number of electrons that element lost or gained in order to be in that compound, in order to combine with those elements and form the compound. That is what we call oxidation number. It can be positive, it can be negative. It will be positive if the element in question lost electrons to be in the compound. And it can be negative if the element in question gained the electron to be in that compound. Okay? So the valency of sodium is 1. That of chlorine is 1, so we already know that. When sodium forms compound with chlorine, as in sodium chloride, the oxidation state of sodium is 1 because sodium lost electron to chlorine. Why that of chlorine is minus 1? Because chlorine gained the electron to form that compound. Are you getting it? So for them to form this compound, sodium lost 1 electron. So the oxidation state of sodium is plus 1. Because when an atom loses electron, it becomes positively charged. While chlorine gains 1 electron, which makes it negative 1, minus 1. Because when an atom gains an electron, it becomes negatively charged. Okay? Alright. If you are still confused on this, please refer to your chemical combination. That will help you. But we need to focus on oxidation number. Then, first of all, I want you to know that there are some elements that have fixed oxidation number. Their oxidation numbers don't change. It is like that everywhere. But there are elements that have variable oxidation number, and that is why we have to find out how to identify the oxidation number of such elements. For those that have fixed oxidation state, you don't have a problem with them. For instance, sodium has an oxidation state of plus 1 in every element. So when you see sodium in every compound, you will find out that the oxidation state of sodium there is plus 1. It always loses 1 electron in each compound. Potassium is plus 1. Calcium is plus 2. Magnesium is plus 2 because in every compound of magnesium is found to lose 2 electrons. Chlorine is always -1, except in few cases. Oxygen is always -2. Zinc is always +2. So why we are giving this is that, why I gave this on the screen is that you should get used to these ones that have fixed oxidation state, because if they are asked questions about oxidation number, they won't give you this because they are meant to know them already, that their oxidation states don't change. But these ones that have variable oxidation states, you may be asked to find that. Are you getting me? So that is why we are treating oxidation state. Copper can be +1 or +2 depending on the compound. Iron can be +2 or +3 depending on the compound. Lead can be +2, +4 depending on the compound. Nitrogen can be from +1 to +5 depending on the compound. Sulfur can be +4 or +6 depending on the compound. So is manganese and chromium. Are you getting me? So these ones with fixed oxidation state, I urge you to memorize them. It's common. So let's solve some examples. Finding the oxidation numbers of elements in a compound. In finding the oxidation numbers of elements in compound, there are points you should note. Rule 1. The oxidation state of an element in free state is 0. For instance, sodium, normal sodium, neutral sodium has no charge, so the oxidation number is 0. Neutral carbon has no charge, so the oxidation number is 0. Hydrogen in free state, hydrogen exists as that atomic molecule, that is H2. So in free state, look at it, it has no charge, so it is 0. Oxygen has no charge, so it is 0 in free state. Note that if it is in compound, then you know they will have charge. Then another rule is that the sum of the oxidation state of all atoms in a neutral compound is 0. For instance, if you have sodium chloride, if you look at this is a compound, there is no charge on sodium chloride. So what it means is that if you add the oxidation number of sodium and that of chlorine, everything will total and give you 0. If you are talking about calcium oxide, it is a compound, and if you add, what it means is that there is no charge on this because it's a compound. If you add the oxidation state of carbon and calcium and oxygen, it will give you 0. That is what it's saying. The third rule says the sum of the oxidation state of all atoms in an ion is equal to the charge. We shall meet that in our example. The oxidation state of group 1 elements are normally +1. That of group 2 elements are normally +2. Oxygen is -2. Always, I have written that in the previous slide about those that have fixed oxidation state. So let's go to example 3. Find the oxidation state of sulfur in the following compounds. We have sulfur in this compound. So the first one says oxidation state of sulfur in SO2. Oxidation state of sulfur in SO3. Solution. The first one says oxidation state of sulfur in SO2. So what you look at is, remember this is SO2, is a compound. The sum of the oxidation state will give you 0. So what it means is that oxidation state of sulfur plus that of oxygen is equal to 0 because there is no charge on this compound. So finding the oxidation state of sulfur, we say sulfur plus 2 oxygen equals to 0. So sulfur plus 2, because we have 2 oxygen here, plus 2 into what is the oxidation state of oxygen in a compound? It is fixed, so it is -2. So you have 2 times -2 because 1 is -2, 2 will be 2 times -2. This will give you everything will total equals to 0. It's equal to 0 because there is no charge on the whole compound. So this will give you S, sulfur plus -4 equals to 0. Sulfur equals to +4. So the oxidation state of sulfur in this compound is +4. Then the second question says the oxidation state or number of sulfur in SO3. Here we have 3 oxygen. So S plus 3 oxygen will give you 0. Remember root 2, because this is a compound, the total will give you 0. So S, which is sulfur, plus 3 into oxidation state of oxygen is minus 2 always. Then this will be minus 2 times 3 equals to 0. This will give you S equals to plus 6. So oxidation state of sulfur here is plus 6. So if you come to the third one, the third one is oxidation state of sulfur in this radical. Remember, this is SO42 minus. This is not a neutral compound, it has charge. So remember also, root 3 says that the sum of the oxidation state of a radical is equal to the charge. So what it means is that oxidation state of sulfur plus that of oxygen will give you the total charge, which is minus 2. So we have S plus 4 oxygen equals to minus 2. Sulfur plus 4 into minus 2, which is the oxidation state of oxygen, this oxygen, will be equals to minus 2 because of this. Alright. So sulfur plus minus 8 will give you minus 2. So if this crosses the sign of equality, you have sulfur equals to plus 6. So the oxidation state of sulfur here is plus 6. Let's try one more example and we'll end there. Find the oxidation state of chromium in the following. We have K2Cr2O7 and K2O7 minus. Finding the oxidation state of chromium here. Remember, we know that the oxidation state of potassium, which is K, is fixed and is plus 1. That of oxygen is fixed, so fixed too, and is minus 2. So what we do now is that the oxidation state of potassium plus that of chromium plus that of chromium plus that of oxygen will give you 0 because this is a compound. So what we have is 2K because we have 2 potassium here, 2 chromium because we have 2 chromium plus 7 oxygen because we have 7 oxygen equals to 0. So what is the oxidation state of potassium? Plus 1. So we have 2 times plus 1 plus, we are looking for that of chromium. So we have 2 chromium already because we have 2 chromium here. Plus the oxidation state of oxygen is minus 2. And how many oxygen do we have? 7. So we have 7 times minus 2. So this will give all total and give you 0. So what we have now is 2 chromium collecting like 10. 2 chromium plus 2 plus minus 14 equals to 0. So we have 2 chromium equals to 12. Then chromium, divide both sides by 2. We have chromium equals to 12 over 2. So equals to 6. So the oxidation state of chromium, oxidation number of chromium here is plus 6. Are you getting it? So you can pause this video and go through the calculation. The second one says the oxidation state of chromium in this ion. So just like before, the total of these will give you minus 2. So we have 2 chromium right here and 7 oxygen will give you equals to minus 2. So we have 2 chromium. Chromium is the one we are looking for. And we already know that oxidation state of oxygen is minus 2. It's always fixed. So we have 7 times minus equals to minus 2. So 2 chromium plus minus 14 will give you minus 2. So if you, this will give you 2 chromium equals to minus 2 plus 14. Chromium equals to 12 over 2, which will give you plus 6. So the oxidation state of chromium here is still plus 6, even though this is ion and this is a neutral compound. I hope you understand. Using what I have explained, I would like you to try your hands on this study question. And when